In last lecture, we saw about Python decision making statements, and in this lecture, we have to learn about Python operators. So, first of all, contents. In this lecture, what we have to learn is first of all Python operators and its types, and arithmetic operators and example, comparison operators and example, assignment operators and logical operators, bitwise operators, membership operators, identity operators. These are the topics that we have to learn in this lecture. And first of all, what is a Python operator and what are its types? So first of all, Python operators are the constraints which can manipulate the value of operands. So here, these operators are nothing but the symbols that we are using for the purpose of arithmetic, logical and various other operations. So sometimes we have to perform arithmetic and sometimes we have to perform logical operations in our programming. Then we are using Python operators. So here consider the expression 4 plus 5 is equal to 9. Here 4 and 5 are called operands and plus is called arithmetic operator. So here and like that we have different operators in Python. Those are arithmetic, logical and various other operations like bitwise operations. And so see here 4 plus 5 is equal to 9. 4 plus 5 is equal to 9. Here 4 and 5 are called operands. 4 or 5 called operands. And here this is called operator. Which operator it is? It is arithmetic operator. So it is a symbol which performs arithmetic operation. So it is called an operator. And so the different types of Python operators is arithmetic operators, comparison operators. In comparison operators, we also called as relational operators, assignment operators, logical operators, bitwise operators, membership operators, identity operators. These are the operators that supports Python. And next, first of all, we'll see one by one with example. First one is Python arithmetic operators. Here, Python arithmetic operators are used to perform mathematical operations on numerical values. So it will perform mathematical operations. Mathematical operations are nothing but addition, subtraction, in multiplication, division, modulus, exponent, floor division. These are the mathematical operations and that performs on numerical values. So these are the operators that perform mathematical operation on numerical values, nothing but the arithmetic operators. And these operations are addition, subtraction, multiplication, division, modulus, exponents and floor division. Here this is the addition operation. 10 plus 20 is equal to 30. 20 minus 10 is equal to 10. 10 into 20 is equal to 200. 20 by 10 is equal to 2. 20 modulus 10 is equal to 2. 4 exponential 2 is equal to 16. And 9 floor division 2 is equal to 4. So here one thing we know about difference between modulus and division and modulus. So here the modulus gives after performing division, it will gives the remainder. It will gives the division gives the coefficient. So it will stores the division stores the coefficient and modulus gives the remainder. And floor division means it converts the float value into integer value. So it converts any float value into integer value. After performing division, sometimes we get float values in the coefficient. So it will converts the float value into int value, integer value. So this is about arithmetic operators. Now for better understanding, we'll see an example. First of all, initially a is equal to 21. That means that value of 21 is stored in the variable a, and b is equal to 10. The value 10 is stored in b. First of all, we have to see addition operation. For addition operation, we are using plus symbol, that is plus operator, addition operator. a plus b. So we have to print like this, a plus b, and here we are using a plus b, addition operator. So when we are using addition operator, then it will perform addition operation. It will perform 21 plus 10, that is 31. So it will print 31. And subtraction, for subtraction a minus b, so it will print 21 minus 10, 11. And for multiplication a star b, it will gives 21 into 10, 210. And for division a by b, 21 by 10, how much? The quotient is 2.1. And for the modulus is 1. And when you are performing the modulus, it will give the remainder. So the remainder is 1. 21 by 10, nothing but the remainder we get 1. So it will print the 1. And a exponent b, it will gives the 166. This is the value for exponential of 21 and 10. And for floor division, it will gives the integer value. So in when we perform division, we get 2.1, but here we get 2, because it will convert the float value into integer value in floor division. So this is the example for arithmetic operators, and I hope that everyone understand about arithmetic operators. I explained the example on arithmetic operators. Now we will see that code is running or not in online Python compiler. So here I simply pasted that program here that I wrote. So this is the program that I explained you. A is equal to 21, b is equal to 10, and first of all we have to perform addition for a plus b, and for subtraction a minus b, and for multiplication a into b, for division a by b, for modulus a percentage b, exponent, and floor division. So these are the arithmetic operations that we perform on a and b. So now we will see this code is executing or not. Yes, this code is executing because there is no errors in that program. So first of all it will print a plus b. Here in a we have 21 and b we have 10. So then what we get, a plus b is equal to 21 plus 10 is equal to 31. And 21 minus 10 is equal to 11. A into b, 21 into 10 is equal to 210. A by b, 21 by 10 is equal to 2.1. It will use coefficient. And a percentile b is equal to 1. 20 percentile 10 is equal to 1. And 20 exponential 10 is equal to 1667988097820. And a floor division, 20 floor division 10 means 2. So it converts coefficient of float value into integer value. So this is the output for that program. How to learn about Python logical operators. And first, before going to Python logical operators, first of all we have to see Python comparison operators. So Python comparison operators is also called as relational operators. Here we are comparing the two values or two strings, anything we are comparing. They are also called as relational operators, and it decides the relation. So here those operators are equal, not equal, greater than, less than, greater than or equal to, and less than or equal to. These are called comparison operators. That means these compare the values on either side of them and decide the relation among them. So these are the Python operators, Python comparison operators. First of all, is equal to 4 is equal to 5. Is 4 is equal to 5? No, it is not true. And here 4 not is equal to 5. That is true. And 4 greater than 5. It is not true. 4 less than 5 is true. 4 greater than is equal to 5 is not true. 4 less than is equal to 5. It is true. So this is way, these are the Python comparators, and these are the symbols for using comparison operators. And now we see one example. First of all, initially a is equal to 5, a is equal to 4 and b is equal to 5. Here first of all we are using equal operator. It will compare the a is equal to b. Is a is equal to b, is 4 is equal to 5, it is not true. So it will print false. And for not equal, a not is equal to b. Yes, of course a is not equal to b. So it will print true. And greater than, a greater than b, 4 greater than 5, it is false. So it will print false. A less than 5, 4 is less than 5, yes it is true. So it will print true. And greater than or equal to, 4 greater than or equal to 5, is 4 greater than or is equal to 5? No, it is false. So it will print false. And less than or equal to, is 4 is less than or equal to 5, you see it is less than or equal to 5, so it will print true. So in this way it will compares the both operands and it gives the relation among them. So here if the condition is true, if the condition is true it will execute true, otherwise it will print false. And this is the about example of comparison operators. I explained you about Python comparison operators example. Now we'll see that code executing or not in online Python compiler. So I simply pasted that Python comparators program in here. So this is the program for Python comparison operators. So first one is equal operator. We are assigning a is equal to 4 and b is equal to 5. For equal operation, a double is equal to b means it compares. If a double is equal to b, it prints true, otherwise it prints false. And a not is equal to b. If a not is equal to b, then it will print true, otherwise it will print false. If a greater than b, it will print true, otherwise it prints false. If a less than b, it will print true, otherwise it prints false. And for greater than or equal to, if a greater than or equal to b, then it will print true, otherwise it prints false. And less than or equal to, if a is less than or equal to b, then it will print true, otherwise it will print false. Now we will see the code is executing or not. So the code is executing. A double is equal to b means here what we taken in a is equal to 4 and b is equal to 5. So here 4 double is equal to 5 is false value. So it will print false. A not is equal to 5. 4 not is equal to 5 is true. So it will print true. And 4 greater than 5. So 4 is not greater than 5, so it will print false. 4 is less than 5. Yes, it is true, so that's why it will print true. A greater than is equal to b. So a is greater than is equal to b. 4 is greater than is equal to 5. It is false. And 4 is less than is equal to 5. It is true. So this is the output for that code. Python assignment operators. And here Python assignment operators are used to assign values to variables. And these operators include simple assignment operator, addition assignment. So here for assigning values to variables, we are using assignment operators. For example, a is equal to 5. Here we are assigning 5 value to the variable a. So that means we are assigning. For assigning purpose we are using one operator is equal to. So here this is called assignment operator. So in this way we have some assignment operators also. We have some types. So those are simple assignment operator, addition assignment operator, subtraction assignment operator, multiplication assignment, division assignment, and assign operators, floor division assignment operators. So these are some of the Python assignment operators. So and these are the symbols for assignment operators: is equal to, plus equal to, minus equal to, star is equal to, slash is equal to, percentage is equal to, 2 stars, 2 slash. So these are the symbols for Python assignment operators, and this is the example. Here consider this example. First of all, a is equal to 10. That means we are assigning 10 value to the variable a, and a plus is equal to 5. A plus is equal to 5 means a is equal to a plus 5. So the value is a is equal to a plus 5. Initially the value is 10. 10 is equal to 10 plus 5. That is, it will store 15. So a minus is equal to 5 means a is equal to a minus 5. A into is equal to 5 means a is equal to a into 5. A slash is equal to 5 means a equal to a slash 5. A percentage is equal to 5 means a is equal to a percentage 5. And a star star 2 is equal to 2 means a is equal to a exponential 2. And a floor division is equal to 3 means a is equal to a floor division 3. So these are the examples for assignment operators. Now we will see one example program on assignment operators. So here first of all assignment operators. First of all, initially we are assuming a is equal to 100. For addition assignment, a plus is equal to 5 means a is equal to a plus 5. Initially we have a is equal to 100. That means 100 plus 5 is equal to 105. So it will print 105. Next, for subtraction assignment, a minus is equal to 5. So here 100 minus 5, that is, it will print 100. 105. Initially we are performing addition operation here. Addition, after addition, a value, how much? A value is 105. So now we have 105. Later we are performing subtraction assignment. So a is equal to a minus 5. So already we have a value is 105. 105 minus 5 is 100. So it will print 100. And for multiplication assignment, yes, a into is equal to 5. A is equal to a into 5. So here after performing subtraction, the value of a is 100. So now for performing multiplication, a is equal to 100 into 5. 100 into 5 is 500. So it will print 500. Now the value of a is 500. And now 500 is equal to 500 by 5. It will print 100. Now the value of a is 100. And 100 modulo 3. 100 modulo 3 is 1. And later the value of a is 1. 1 exponential 2 is 1. And later also the value is 1. Value of a is 1. 1 floor division 3 is equal to 0. So in this way we are performing assignment. Now we will see example for Python assignment operators. So I pasted that program here. So this is the program for assignment operators. First of all, we are initializing a is equal to 20, and for addition assignment, a plus is equal to 5. So here we are taking, here take here as 100. And for addition assignment, we are assigning a plus b is a plus is equal to 5, and that means that a is equal to a plus 5. For subtraction assignment, we are writing as a minus is equal to 5. That means a is equal to a minus 5. For multiplication assignment, we are writing as a into is equal to 5. That is equal to a is equal to a into 5. For division assignment, a slash is equal to 5 means a is equal to a divided by 5. And for remainder, a percentage is equal to 3 means a is equal to a percentile 3. And for exponent assignment, a exponential is equal to 2 means a is equal to a exponential of 2. And for floor division assignment, a double slash is equal to 3 means a is equal to a double slash 3. So now we observe that the code. Now we get 105, 100, 500, 100, 1, 1, 0. So here in A we are taking 100. So A plus is equal to 5. That means that A is equal to A plus 5. A we have 100. 100 plus 5 is equal to 105. And now the value of A is 105. 105 minus is equal to 5. That means that 105 is equal to 105 minus 5. The value of 105 minus 5 is the 100. And now the value of A is 100. In A we have 100 value. So now A into is equal to 5. In A we have 100. 100 into is equal to 100 into 5 is nothing but a 500. And A slash is equal to 5. Now we have in A value 500. 5 divided by 5 is nothing but a 100. So it will print float value. Because we are not using two slashes, that means float division. Here we are performing normal division, so it will give float value. And now the value of A is 100. 100 modulo is equal to 100 modulo 3 is nothing but a 1. And now the value of A is 1. 1 exponential 2 is, the value is 1. And the value of A is now 1. 1 double slash 3 is nothing but a 0. So this is the output for Python assignment operators example. And another type of operators is Python bitwise operators. Now we see the Python bitwise operators. Bitwise operators works on bits and performs bit by bit operation. It will perform bit by bit operation and assume, and it converts the it is first of all in bitwise operators we are performing binary form. We are converting the number into binary form. So in the binary form of the digit, it will perform bit by bit operation and assume if A is equal to 60 and B is equal to 13. So here A is equal to 60. The value of 60 is in binary form is 00111100, and the value of 13 in binary form is 401101. So these are the values for binary form. First of all, initially we have to perform AND operation. So here for performing binary AND, the condition is set each bit to 1 if both bits are 1. If first of all we are performing bit by bit operation. If the both bits are 1, then it will print 1. Otherwise it is 0. So here 0 and 1 is 0, and 0 and 0 is 0. 1 and 1 is 1. So in this way it will perform AND operation. And this is a symbol for OR operation, binary OR. So here set each bit to 1 if one of two bits is 1. If any one of two bits is 1, it will print it, the output is 1. So here first of all 0 or 1. If any here 1, here second bit is 1. So here it is 1, and 0 are with 0, 0. 1 are with 1, 1. So it will performs, in this way it will performs binary OR operation. And A complement A XOR B. A XOR B, this is the symbol for XOR operation. And here sets each bit to 1 if only one of two bits is 1. If only one of two bits is 1, then it will set to 1. Here 0, 1, 0 XOR with 1. So it will print 1. Here 0 XOR with 0. So here there is no bit is set to 1. So the output is 0. So in this way it will perform bit by bit is operations, and later it will print A XOR B is equal to 49. And binary ones complement. So it will perform ones complement. So the ones complement, binary ones complement inverts all the bits. It will inverts the all the bits. and A less than A binary left shift. This is the symbol for left shift. 240. When we performing left shift operation and shift left by pushing zeros in from the right and let the leftmost bits fall off. So and this is the binary shift. This is shift left by pushing copies of the leftmost bit in from the left and let the rightmost bits all falls off. So these are the bitwise operators. Now we'll see with one example. First of all, initially A is equal 60. It is a binary form is 004100 and B is equal to 13. Binary form is 401101. First of all, we have to perform binary AND operation. So here 0 1 is 0, and we know everyone we know about AND operation. If any one of the bit is 0, then the output is 0. So here in this it will performs AND operation. After performing AND operation, it will get output as 12. And binary OR, it will perform binary OR operation. It will perform binary XOR operation, binary ones complement, binary left shift, binary right shift, and these are the outputs for that example. And now we'll see example for Python bitwise operators. I pasted here the program for Python bitwise operators. This is the program for Python bitwise operators. Bitwise operators are nothing but a binary AND, binary OR, binary XOR, binary ones complement, binary left shift, binary right shift. So these are the Python bitwise operators. First of all, we are initializing A is equal to 60 and B is equal to 13. In binary form, the value of 60 is 00111100, and the binary form of 13 is the 401101. These are the binary values for 60 and 13. Now we'll perform bit by bit operators. So first of all, C is equal to AND B. The AND operation is if any one of the input is 0, then the output is 0, otherwise the output is 1. So here we are performing bit by bit operations, and for example for 60 and 13 means first of all we have to compare 0 and 1. So when we perform 0 and 1, we get output as 0. So this is the output. And next 0 and 0, that is nothing but 0. And 0 1 and 1 is 1. 1 and 1 is 1. So here this is the operation of AND operation. Like that it will perform bit by bit operation. So the output will get 12. And for binary OR, C is equal to A or B. This is the symbol for binary OR. And we get 61 we get. So the OR operation is if any one of the input is 1, the output is 1. That is opposite to AND gate. In AND gate, if any one of the input is 0, the output is 0. Here, if any one of the input is 1, the output is 1 for OR gate. And binary XOR. Binary XOR is equal to, this is the symbol for XOR, A cap B. So for binary XOR, if any one of the if two inputs are same, then the output is 0. Otherwise, the output is 1. For example, if the two inputs are, if the two digits are, if the two digit inputs are 0 0, then the output is 0. If the two inputs are 1 1, then the output is 0, because the two inputs are same. If the two inputs are same, then the output is 0, otherwise the output is 1. After performing that operation between A and B, we get the value as 49. And binary ones complement. Ones complement is nothing but a, here it will performing converting zeros into ones and ones into zeros. Here see, observe clearly that here in binary one's complement of A is nothing but a, so A is the 00111100. So ones complement means it will convert the ones into zeros and zeros into ones. Now we will get 1100 0011. So 1100 So this is the ones complement for 61. Now the value of 61 is minus 61. Print. So this is the value for after performing negotiation or ones complement. Binary left shift. So it will shift the left up to 2. It will shift the 2 bits left side. After performing that, we get 240. And binary right shift. Here we are shifting the bits towards right. After performing this operation, we get 15. So this is the binary bitwise operators. Now we will see the output. So this is the output for binary bitwise operators example. In A and B we get 12, and A or B we get 61, and A complement B, A XOR B we get 49, complement of A we get minus 61, and A left shift 2 is nothing but a 240, A right shift 2 is equal to 15. So this is the bitwise operators example. Python logical operators. Here Python logical operators. First of all, we have Python logical operators are 3. Those are AND, or, NOT. Those are logical AND, logical or, logical NOT. So here if for logical AND, if both operands are true, then condition becomes true. Okay, and if any one of the two operands are non-zero, then condition becomes true for OR operation. For logical NOT, it is used to reverse the logical states of its operand. And this is the description of logical operators. Now we will see Python membership operators. So here Python membership operators test for membership in a sequence such as strings, lists or tuples, and there are two membership operators as explained below. Here the two operators are in and not in. These are the two Python membership operators, and the description of this is it evaluates true, it finds a variable in the specified sequence and false otherwise. If the value it finds a variable in the specified sequence, then it will evaluates as true, otherwise it evaluates as false. And for not in, it evaluates to true if doesn't find a variable. Here it finds a variable. Here it is doesn't find a variable in the specified sequence, it will print true, otherwise it evaluates as false. For example, for in operator, the example is x in y. For example, x is present in y. Then here results in a 1. Why? Because it is a member in y. So that's why it will print true. X not in y. Here not in results in a 1. Suppose if x is not in y, then it will print 1. Why? Because we are saying that x is not in y. So it will print 1 because it is not a member of y. So this is about membership operators. Identity operators. Here identity operators compare the memory locations of two objects, and there are two identity operators explained below. Those are is and is not. Here is not evaluates to true if the variables on either side of the operator point to the same object, and false otherwise. For example, x is y. Here x is y. Here is results in 1 if id of x is equal to id of y. If x is equal to y, then it will print to 1. If x is not y, then it results in 1 because it is true. If id of x is not equal to id of y, then it will print true. And these are the identity operators. In this lecture, we learnt about Python types of Python operators and assignment operator, logical operators, comparison operators, bitwise operators, and assignment operators and identity operators, membership operators. These are the Python operators, and I hope that everyone understand this lecture with examples. And if you like this lecture, you can subscribe my channel to get more videos on Python. Thank you.